speaker.
Essentially.
So today we're going to present our plasma arc speaker. So essentially the concept that we have is that we're using high voltage to rapidly expand and contract air so that we can create sound. And to create that sound, we have to use the high voltage in a very specific way, which we have accomplished through our use of the Arduino. So for materials, we used many components that we ordered from Amazon. Our code is pretty short, but it took a long time experimenting with libraries that involve the use of the Arduino's internal timers. So we eventually settled on the code AC library for our code. The hardware is some of the components that we used. So we used the Arduino high voltage transformer, a potentiometer, and the floor we have wires, a small circuit board, and a power source, and an REJ. So our project here has three modes of operation. The first mode is just the standard high voltage arc, which just creates a boring high voltage arc that has no sound and is completely quiet. Because it runs at 50,000 kilohertz. 50,000 hertz, yeah. So as you can see, we have a high voltage arc here, and it's running at 50,000 hertz, so you cannot hear it. Okay, then if you change the So in this configuration, it should be able to play a tone based on the frequency we determined by potentiometer. Oh, okay, so So, yeah, I have a potentiometer inside a casing, which I am turning to increase/decrease the frequency that we're running the transformer at. And the final mode of operation, it allows us to play music through an audio cable, which I've connected to my laptop. So anyone have any suggestions of what I could play?
Classical music.
I don't know.
Yeah.
I think it's kind of like YouTube or something. Just go there, sure.
YouTube, whatever.
Wait, hold up. Actually, I think I have something else I want to try to play. I'm just gonna try to play like some video.
Just right now.
Okay, so I'll just say I was like watching some videos about electronics earlier, and I'm just gonna try using this as a speaker. Like it is free. Anyway. Oh. Let's switch this over. switch so that choose the first one. Alright, so stop disconnecting. Alright, so I think that should work. So okay, so if I'm trying to like play some audio through this, say I'm just gonna go to like a video about like say electro boom. Now we're having an ad, but as you can see, the audio is played by the high voltage arc. Yeah, that's the max volume. So that's the max volume. I mean, I could make it a higher volume if I was still with a larger arc. Okay, just get a bunch of random ads.
Hi, today I'm going to do something that will not shock you or me or anyone for that matter.
Yeah.
I'm going to take
It
my
basically just plays the audio,
dangerous
and how it works is that I have a MOSFET. Do this somewhere. Yeah, okay. So how we made it work is we have the Arduino output a 50,000 hertz square wave, which is what we need to power the transformer in the first case. So that's what we used during the first operation. It was just the Arduino outputting 50,000 hertz frequency, which we used the MOSFET plus our power supply to then power the transformer and create a high voltage of a couple kilovolts. Next what I did was I used my Arduino once again. I used the code of the Arduino to make it so that it would read the input that it gets from a potentiometer, and then use that to create a different frequency that it interrupts the 50,000 hertz frequency by. So like let's just say we were trying to make 100 hertz noise, then it would have a 50,000 hertz, like it would essentially be a 100 hertz square wave, but that also like added to a 50,000 hertz square wave, like if you use the AND gate to combine them. And then the final version, we have a 50,000 hertz square wave once again, but I've used the potentiometer to bring down its amplitude a little bit, such that we can create it, such that we can put a sine wave on it, so that, and since the MOSFET works by allowing more current depending on how much voltage is applied to it at like a very small range, we have the sine wave, which is then at that small range while it's being like changed, like it's basically riding on like square waves. It's kind of complicated to explain without an oscilloscope, like show the waveforms, but essentially it works by turning the transformer on and off at both 50,000 hertz, which is required to keep the high voltage, as well as the lower frequency that we're trying to play. So we took inspiration from inspired by many other projects similar to this, but I noticed a big flaw with all the other projects was that their frequencies that you drove your transformers on were in audible range, so it had to create a high pitch like noise along with your audio output. So I decided to try to make a new design that would change that, and this is the design.
How many volts are you using
For like what?
to like power? You said it uses voltage to make the sound, right?
Yeah, the high voltage, well, we can't really measure the high voltage that well. I'd say like a couple kilohertz, like probably 3 to 10 volts.
Okay, so yeah, makes sense.
Any other questions?
Yeah, how many amperage?
Amps, definitely like the microamps, because it's not very high amperage. It's just mainly just the all plasma that's there.
So what's causing the increase in voltage?
Like the increasing voltage?
Yeah.
So it's like a high voltage transformer. So the primary I'm not really too sure about how many windings the coil has, but I can unplug it here and show it to you. So all of these windings that you see with like this smaller wire, it's very thin wire. It's around like I'd say almost like 1,000 times around this iron core in the middle. And the primary is like inside the iron core, and I believe it has like around like I don't know, probably 10, 20 windings, I'd say. 18 volts DC to it at its like resonant frequency, then it can build up a lot more voltage on the output because it's a ratio of the primary secondary can build a couple thousand volts on the other side.